Hey y'all, Miss Harper here with our pre-AP algebra class. Awkwardly watching. It's going to be fine though. Okay, we're going to start here with our notes on simplifying. So if you remember, simplifying means that there is not an equal sign happening in this thing most of the time. All right, so something to remember is double distribution. Another word for that is called FOIL. I don't really like to call it that very much, so we mostly called it double distribution. Other things that we might need to do would be distribute and combine like terms, which I like to abbreviate as CLT, combine like terms. One other bit we're going to need to remember is function notation. Alright, so look at these two. These are the two flavors they come in. Can you remember which one represents an x value or which one represents a y value? Well, remember f of x is a fancy word for
y equals.
Y equals. So this one is telling me y equals 3. And this one, if you think the 2 is in place of x. This one is telling me that it's an x value of 2. So if they give me a y value, I plug it in for y and I solve for x. If they give me an x value, I plug it in for x and solve for y. Let's go ahead and look at these first couple of examples here. A rectangle has a length of this and a width of that. Which expression best describes the area? Now, if you look at your star formula chart, it does not give you the area of a rectangle anymore because you're not in 4th grade. So this is something you're going to have to remember. To find the area of a rectangle, we use length times width, and that's something that you will need to remember. So I'm going to set this up. Remember, anytime we're working with something like a binomial, something more than one term, we need to put those things in parentheses so we can multiply correctly. Alright, so this is where our double distribution happens. So 2x times 5x is 10x squared. So right off the bat, I can eliminate 2 wrong answer choices. Alright, next I'm going to distribute the 2x again to the negative 4. 2x times negative 4 is negative 8x. Distribute my 1, I get 5x, and 1 times negative 4 is negative 4. Alright, remember on these, there's always going to be an extra step to combine like terms. So this is going to become 10x squared minus 3x minus 4. And that is our final answer. Now I want to show you a quick calculator trick here too. A way to check yourself. So let's see, we had 2x plus 1. Oh, let me do this. 2x plus 1 times 5x minus 4. Alright, and then I could plug these in, or if I just wanted to confirm my answer choice here. Well, these things should be equivalent to one another because all I did was simplify. So if I plug these into my calculator, I could go look at my graph, and we could see that they're either going to be graphed as the same function. So there's the first one, and here comes the second one maybe. Oh, okay, it's not going to draw it in. Oh, there it is. As you can see, it laid right on top of the other one. That's because these things are equivalent. If I go look at my table, all of my x values are going to be the same, but this is my first graph, or my first equation, and this is my second equation. We can see all of those points match up, so that means I know I got the correct answer here for this one. Alright, let's look at our second example. Which expression is equivalent to this? Now notice again, there's not an equal sign. So here, I'm going to be distributing and combining like terms. First, I want to distribute that negative 7. Then I'm going to distribute this 5. That's going to become negative 7x. Negative 7 times negative 2 is a positive 14. 5 times 3 is positive 15. 5 times negative 1x is negative 5x. And then I have my negative 4x. Alright, now remember there's not an equal sign here, so I'm not going to use opposite operations because I'm not moving to the opposite side of an equal sign. I'm just going to combine like terms as is. So in my calculator, I'm going to do negative 7 plus negative 5 plus negative 4, or I could have done negative 7 minus 5 minus 4 for a total of negative 16 x's. And then from here, 14 and 15 adds to a positive 29. Now remember, another way you might see your answer listed on your STAR test could be something like this. Now look and see those are the same values because we have a positive 29 and a negative 16. Alright, here on our third example, given this function, what is the value of f of negative 3? Well, first off, you have to remember, what is this telling me, an x value or a y value? Well, if you look at your notes, this is telling me x equals negative 3. So that means I'm going to replace any x in my function with a negative 3. So I can say 3 parentheses negative 3 squared minus 7. Remember, anytime you're inputting something into your equation, you need to use parentheses, and I'm going to show you why. Alright, let's say I didn't use parentheses. I was just being lazy. Oh, negative 34. Oh, B. That's my answer choice. Wrong. They're trying to trick you. They know you're lazy. They know you're going to do that. You have to use your parentheses each and every time. And as you can see here, I get positive 20. Now, another option would be to go plug in my function into y equals. So this is 3x squared minus 7. And go look at my table. They asked what is y when x is negative 3, and when x is negative 3, I see that y is positive 20. So again, using that graphing calculator, using that to our advantage, plugging those things in and using our table. Alright, the area of a rectangle, again, that's going to be a popular question. The area is this. The width is this. Which expression best describes the length? Alright, so first, what are our answer choices here representing? Well, they're giving me options for the length, right? And I know what my width is, so we have a couple different ways to approach this problem. One, you could use the same strategy, kind of like we used in the first example. But what I would say is y'all are better at multiplying than you are at factoring. So essentially, they gave me the lengths. I already know my width. What if I just distributed to see which one took me back to my original area? And again, this is a way to use those answer choices to our benefit. Right off the bat, there's typically 2 answer choices you can automatically eliminate. So right here, if I do 2x times x, well, that's only going to give me 2x squared, as is this one. So now I only have 2 problems to deal with. From here, well, I always like to look at first and last terms. Now look at this one. This is negative 2 times positive 4. Well, that'll give me negative 8, but I need it to be a positive 8, so F has to be my answer here. I do want to pause real quick and talk about factoring, though, because on your practice sheets, you are going to be required to factor. So let's remember our factoring steps. Now, this looks a lot different for everybody, and even in my classes, we're taught different ways. So I'm going to go ahead and do factor by grouping here. Alright, so a times c would be 3 times 8, which is 24, and my v value is 14. I list out my factors of that number. Which of those has a chance of adding to 14? Well, 2 and 12, and they both get to be positive. So in this first step, remember we're replacing our b term. Most common mistake is one that I'm making right now. Did you catch it? What did I forget to add here with the 2 and the 12? Our x's. So don't forget that. Group them with parentheses, and now we factor out a GCF. My GCF in the first group would be 1x. Divide out the x and see what you're left over with on your insides. That would be 3x plus 2. Over here, my GCF would be a 4. Divide out that 4. I'd be left again with 3x plus 2. Our checkpoint here is to see do we have matching parentheses, in which case we do. So I take what's left over on the outside. That is an x and a positive 4. And then one of the matching twins, 3x plus 2. So I already knew this factor. That was the given width. And so my new factor, or my length, would be that 3x plus 2. All right, shimmying down for solving. Let's add a couple notes in here. All right, for solving, sometimes we might need to start by writing out an equation if it's a word problem. Second to that, we might need to distribute. Third, CLT, combine like terms. 4, we want to get our variables to the same side. 5, finish solving. And 6, most important, plug in to check. If you're in my class, you know I always say it, check yourself before you wreck yourself. Hopefully you can hear the chime of our pre-AP class in the background there. So the question that we see right here, this would be a common griddable question that you'd come across. Solve this equation. It would say find the value of A, and then you'd be required to bubble that value in. All right, so our first step, do I need to write an equation? Well, no, it already gave me one. So my second step, do I need to distribute? I have no parentheses. Third one, combine like terms right here. I have some like terms. How many total A's do we have on the left-hand side here? 7 minus 6, 3A plus 10. All right, after that step, I want to get my variables to the same side. Does it matter which side I move them to? No. Just pick a side and move them over. So here I'm going to subtract these positive 3A's over here to the left side. Now who am I going to take them from, the A or the 6? Hopefully you know to take them from the A's like terms. So I get 4A minus 6 equals 10. From here we're just down to a two-step equation, and you can finish this one out by adding 6 to both sides. 4A equals 16. And in my last step, I'm going to divide both sides by 4. So I get A equals 4. Now again, check yourself before you wreck yourself. How can I double check myself? Well, this is hopefully an easy problem that I don't want to miss on the test. So I'm going to input it in for all my A values on the left. 2 times A minus 6 plus 5 times A. So this would be the left-hand side of my equation. And this would be the right-hand side. Now, if A is a value of 4, then it should make these two things equal, in which case it is. If you plug those things in and they are not the same number, like they're not both 22 in this case, that tells me I did something wrong. Maybe you added 3A when you were supposed to subtract 3A. Either way, it would force you to go back and double check your steps. On to the back. All right, this is a case where you would first need to start by writing out an equation. So Mr. Jones, he was charged $84 for a part plus $68 per hour. That indicates a variable. The total charge was this. For about how long did the mechanic work to install the part? All right, so y'all are pretty good at writing out these equations. It would be 84 plus 68 H or X per hour. From here, I know that he was charged a total of $353. So you could plug it in this way and go ahead and solve for H. That is one option. Another option would be use that Y equals in our table to our advantage. So 84 plus 68X, and go look at our table. And about when is he going to be charged $353? Well, right here, after 4 hours, it shows $356. That would be about 4 hours. If you solve for H, I think you get H equals 3.95 or something like that. Again, about 4 hours. All right, on this next one, if x comma negative 4 is a solution to this equation, what is the value of x? Okay, what do you think they're trying to tell us with this information right here? Well, hopefully you can recognize that they're telling us y is equal to negative 4. If they give me a y value or an x value, I would like to input that in for the y, or whichever variable they're giving it to us. Negative 5 times negative 4 is a positive 20. That equals 8. Subtract 20 to both sides. I get 4x equals negative 12. Take that party over here. Divide both sides by 4. And I get x equals negative 3. Alright, again, I can double check myself because this is one that we would like to count towards that magic number 30. So 4 times the x value minus 5 times the y value, and hopefully this equals 8 when I plug those in which case it does. Alright, exponent rules, but we also need to split this box because we're going to talk about two other things on here. First thing to know is your exponent rules are on your star sheet or on your star formula sheet. So you don't actually have to have these memorized. About there. Alright, so let's go ahead and write out how they look on your star formula sheet, though. It looks a little weird. A times n, or a to the m times a to the n equals a to the m plus n. Meaning when I'm multiplying things of the same base, I add their exponents. We have this rule. This is the power to a power. And it's going to look like that on your star sheet, meaning what we do here is we multiply those two values. Let's see, other ones. You get a to the negative n equals 1 over a to the positive n. So remember, if you get a negative exponent, you just kick it downstairs or upstairs to make it positive. Then we have the quotient rule. A to the m minus n, meaning we subtract the denominator exponent from the numerator exponent. Now there is one on here that they don't give you, and that is the a to the 0. Okay, so this is one that you would need to know, but you don't really need to know it because you can always test it in your calculator. If you're like, I don't know if it's 0 or 1, well, let's just try in our calculator. 5 to the 0 power. Oh, okay, let me just double check for safe measure. Anything to the 0 power is 1. Alright, so if you see something like that, you can always test that one in your calculator. A couple other things that I want to talk about real quick for your vocab homework are your parent functions. And we're also going to talk about functions. So we have two parent functions. One is the linear parent function. The other is your quadratic parent function. Okay, if you can remember, our linear, the most basic one we have, is y equals x. He has a slope of 1 and a y-intercept of 0. He looks just like this. Hashtag basic. Our other one is the quadratic parent function, y equals x squared. Again, the most basic form of our quadratic functions, and he hits right there at the origin. Speaking of functions, real quick, remember, for something to be a function, that means it has no repeating x values. Or, if you're looking for a graph, it passes the VLT, the vertical line test. Not to be confused with the BLT, very different. Everybody's laughing right now. It's great. All right, so that'll be helpful for your vocab homework. Let's practice some of these exponent rules, and then we will be done. All right, which expression best describes the area of a rectangle that has a width of this and a length of this? Again, you have to know that area is equal to length times width. So for this rectangle, I'm going to say this, again, using those parentheses, times this. All right, I can't stress this enough. Exponent rules only apply to exponents. All right, so 4 times 3. Neither of those are exponents, those are regular numbers. 4 times 3 is 12. Right off the bat, I can eliminate h and j. Again, they think you're going to confuse yourself and that you're going to add those numbers because of your exponent rules, but those are regular numbers. So then I look here, x3 times x2. When I'm multiplying things of the same base, my rule says that I add their exponents. So this becomes x to the 5th and also y to the 5th. But again, they are going to try to confuse you, and they think that you're going to multiply them, and they're going to give you that option. Don't be fooled. Refer to your formula sheet at all costs. You have 5 hours to take this test, so if you're feeling real groovy, don't forget you can always drop this out in expanded form. That's not what I meant to put. 4, 1, 2, 3, y, 1, 2. And then we would be multiplying that by 3, 1, 2, 1, 2, 3. All right, so as you can see here, we'd end up with 5 total x's and 5 total y's, and that is how we get x to the 5th, y to the 5th. All right, on this next problem, first step would be to simplify. Remember, you're still doing order of operations, so you need to handle any parentheses first. Go ahead and multiply across the top. 8 times 2 is 16. X to the 3rd times x to the 5th. Again, we add those exponents and we get x to the 8th all over 4x to the 6th. 16 divided by 4 is 4. And then my next rule is the quotient rule, and it says that I subtract the bottom exponents from the top exponents. So let's say I did that, and I subtracted these 6 up here, I'd get x to the 2nd power. Okay, again, you do have time to do expanded form, 3, 4, 5, 6, 7, 8, all over 1, 2, 3, 4, 5, 6. And from here, you can just simply simplify. 1, 2, 3, 4, 5, and 6. And we'd be left with x squared on the top. So that can help whenever we end up with, like, you know, sometimes we have exponents that end up in the denominator. So you can always take it out to expanded form. Last problem. An area of a rectangle is that. The width is this. What is the length? All right, so again, my answer choices are representing lengths of this thing. So again, area is equal to length times width. Well, what if I was trying to isolate this L here? What's the opposite of multiplying by W? That would be to divide both sides by W, and I could say that the length is equal to the area divided by the width. So that's your first option. I can do my area, divide it by the width, and that would leave me left over with my length. Other option, use those answer choices to your benefit. If this is the length, can't I just multiply it by the width and see which one is going to take me here to my area? Well, do you think 1,000 something times 8 is 144? No, no, no. That one's pretty easy, actually. And if you double check that over here, 144 divided by 8 is 18. Dun, dun, dun. RC1, check.